Good afternoon, may I welcome you to my presentation. Today we are talking about the IBM Watson, the relation extraction system for deep QA. My name is Tobias Paxian and I hope to attract your attention the next 25 to 30 minutes about Watson. Have somebody of you heard of Watson already? Two of you? Three and a half, okay. So let's go on, and I hope to attract your attention for this interesting question answering system. But I'm not alone. I'm here. I want to introduce you as well. Someone else? This is Watson.
Hello, my name is Watson.
Yes, so it was on a Jeopardy show in the United States. But at first, how they came to the idea... next slide, yes. Overview, yes. At first, what I'm going to present you. I make it very shortly. At first, a bit about the history, how they came to the idea to compete in the Jeopardy. Then, what is Jeopardy? Do you all know Jeopardy? Or yes? Yes? Wow, cool. Almost all of you know it. How it works, the system, and an outlook, how it will be in some years maybe. Okay, Deep Blue, 1997, they started with a chess game against Garry Kasparov, on this time the champion in chess, and they won the first time against a computer won the first time against a person. It was the Deep Blue computer from IBM as well. And after this challenge, they thought about, okay, chess. Chess is structured, mathematical, logical. It's a language of computers. Why we have this question about a computer winning against a human? The question should be, how can humans win against computers? It's the definition of how to play chess. It's mathematics, it's logic, it's all these things. But we have, with Jeopardy, we have another problem. A bar. I've heard the chief operator of Watson telling this story at one of his presentations. At first, they met with some IBM co-workers in a bar, and we're chatting about what comes next after Deep Blue. Yes, and what comes next? They saw on a television show there, Jeopardy, and in Jeopardy there were at this time Ken Jennings winning his 74 games in a row. So they decided, okay, could we do this with a computer as well? 2007 we saw last week, it wasn't that high up the level. And 2007 they had the idea of winning against top human players in Jeopardy. Okay, how does it look like, Jeopardy? One too fast. Okay, there are three humans playing against each other, and later on with Watson as well, and there are different categories, and the human players have to select which difficulty they want to play in what category, and the whole board has to be played, and there are some double questions. All of you are familiar with Watson, or some of you not familiar with? Okay, so I can go on. Okay, when Watson's playing Jeopardy, he gives three possible answers, and the first answer he is most confident with is the one on the top. If this answer is higher than the threshold, the white line there in the middle, then he tries to buzzer in and to and he tries to answer the question with his answer. But we are going to have some question examples later on. Jeopardy, the winner cloud, the winner's cloud. So now I was a bit too fast. The winner's cloud. Champions answer an average 40 to 50%. Here around is the average 40 to 50% of all questions. Each dot here represented in this sheet is Jeopardy winner. From 2000 matches, they made all the points here, and each of this little gray dot is a Jeopardy winner. You can see how many questions he answered and the precision of the answer. Some of them even answered all questions correctly. So when you want to have a system winning against humans, you have to answer, your answers have to be so good, so correct, that the line is here in the winner's cloud. And like we heard last week, track was about 40, 50, 2007 for the track questions, even 60-70% accuracy. Is that right? Round about that. Yes?
A little bit earlier.
A little bit earlier, okay. Even. So they adapted the system they had from the track competitions. IBM parted as well in these competitions, and they invested 4 weeks how to get track answering the questions of Jeopardy. The Jeopardy questions are longer, are more complicated. They made some adaptations that it works as well with Jeopardy. On the line you can see here, it was the Piquant system was when he only buzzes in 5% of the time, a bit under 50% of accuracy. But when he would had to answer all questions, its performance was 12-13% correctness. So there was a lot of work to do till they could compete against the human players. They thought about the work around about 4 to 5, maybe 6 years. Will it be until they can compete against Jeopardy players? And there it was, 2010. They were in a match against 2 Jeopardy players. One of them was Ken Jennings. He had an incredible winning strike series, about 74 games in a row he won, and every black dot here up there is a game represented of Ken Jennings. Okay, so let's go on. Now you have a idea of what it's about. Question answering in Jeopardy. I'm a bit too... yeah, here. Given. We have rich natural language questions over a broad domain of knowledge. You cannot categorize that 30% of the questions is about films or about this or that. It's very, very broad domain of different questions. So, and what do we have to deliver? Precise answer. Precision and confidence in 2 to 6 seconds with an average of 3 seconds time to buzz in. So it has to be really, really fast. And in 2007, with the track system, they had 1 week to answer 500 questions. So they had a whole week to run a program over the 500 given questions to answer them. And they had only 2 to 6 seconds, in average 3 seconds. it was a bit too fast. Okay, accurate confidences. You have to be really confident in your answer to buzz in. If you're not, you lose the amount of money you play with. Yes, and consumable justifications. If you're not sure of your questions, you cannot. You have to be sure of an answer to buzz in. And fast response time, 2 to 6 seconds. Knowledge sources of Watson. There are 3 different types of knowledge. Domain data from articles, books, documents. Training and test question sets from Jeopardy with answers. And natural language processing, vocabularies, taxonomies, ontologies. They had about 70 gigabyte of data, a big amount of data from Wikipedia, and the others spread it wide from the New York Times magazine, newspaper, Encarta, Oxford University, but as well from structured information sources like DBpedia. They categorized all the Wikipedia articles and tried to cut out structured information from Wikipedia. And so they had a total raw content of 70 gigabyte and pre-processed content of 500 gigabyte even. Yes. The technology behind Watson. It's a massively parallel probabilistic evidence-based architecture. Deep question answering generates and scores many hypotheses using an extensible collection of natural language processing, machine learning and reasoning algorithms. These gather and weigh evidence over both unstructured and structured content to determine the answer with the best confidence. Okay. Like this, it looks in the brain of Watson, you could almost say. This is the way it works from a really far look over. So, the technology behind Watson. The question. There are many possible meanings of a question. There are multiple different interpretations often of different questions. And each component adds assumptions about what the question might mean. To interpret questions, almost all algorithms you've presented the last weeks are needed to extract structure of the algorithms. It was massively parallel, so they run a big bunch of algorithms over it. And like that, they had the chance to speed it up as well, to make it faster. Question and category analysis. There they are parsing the algorithms, decompose the algorithm into its grammatical components, like we've seen from previous lectures here, how they extract things in grammatical components. Other text-specific entities like names, places, or dates are recognized here. And LAT, lexical answer type, they try to give the question yet an answer type, like fish, it is a fish, it's a country, it's a character. They try to, yet in this early state, to put it in, it could be or is probable that it is this kind of answer. Okay, question decomposing. The question decomposing step, you decompose the question into maybe sub-questions, or you can, we will later on see as well that a question has sometimes some sub-clues, and like a divide and conquer algorithm, they are later on connected to each other again. Hypothesis generation. Now it's spreaded about all the processors. There are many different interpretations, hundreds of different candidate answers. They spread it, it can be maybe that, or maybe that, or maybe that, and they try later on to give evidence on that. Hypothesis and evidence scoring, that they are confident in this answer. They score it. They score each possible answer to get surer that this answer is the right one. The technology. No, there it goes on. Deeper in hypothesis and evidence scoring, there are deeper analysis algorithms, typing algorithms, score indicating how likely it is that this lexical answer type is correct. They found early on, or maybe change it again. Synthesis. There are different methods for inferring a coherent final answer. Maybe they have two different names for the same thing, which means the same fluid and liquid, and but it's the same. So the assurance of liquid and the assurance of fluid are in addition. So it's the both answers are true. So they can combine them and give them a higher final answer scoring. So, and final confidence, merging and ranking. There are trained models which are applied to weigh the relative importance of these feature scores. Merging subclues and confidence. Yes. And, yes, now it goes on. They try to spread it. There are multiple interpretations, hundreds of sources, hundreds of possible answers, thousands of pieces of evidence, and 100,000 scores from many simultaneous text analysis algorithms. And finally, they merge all them. One Jeopardy question can take 2 hours on a single 2.6 GHz core, optimized and scaled out on 2,880 core IBM workload optimized power HPC using UIMAS. Watson answers in 2 to 6 seconds. That's the important thing. They could do it in 2 to 6 seconds. But to what hardware they used, we come later on if we have enough time. Text extraction. Computer programs are natively explicit, fast, and exacting in their calculation over numbers and symbols. But natural language is implicit, highly contextual, ambiguous, and often imprecise. For example, where was X born? It's a good question. It's precise. It's easy to extract the information. Easy for an algorithm. Okay, you have to find the parts born where, and then it's kind of easy for an algorithm as well. But for example, Albert Einstein born in Ulm. It's there you have it structured. So when you have the question, where was Albert Einstein born, you can look up in your database and have the answer. But how is with that question? One day, from among his city views of Ulm, Otto chose a watercolor to send to Albert Einstein as a remembrance of Einstein's birthplace. So we go deeper in the text analysis. We have to analyze this text so that we can give that the answer Albert Einstein Ulm a higher confidence score. Or X ran this, J. Welch ran the organization GE. If leadership is an art, then surely Jack Welch has proved himself a master painter during his tenure at GE. Surely the algorithm at first gave the answer, Jack Welch has proved himself a master painter. Jack Welch is a master painter. So you have to read the answer and get it that if leadership is an art, so he is Jack Welch is a leader of GE and not a master painter. Automatic learning, reading. Yes, he has a big volume of text. We saw yet the amount of data they had. Syntactic frame, subject, verb, object, how to extract them, we've seen yet. And a lot of semantic frames. And the number here behind the point, it's about the confidence they had in this answer, in this in this connection. Inventors patent inventions, officials submit resignations. Fluid is a liquid. Liquid is a fluid. Why they don't have the same confidence? Maybe because I'm speaking a not perfect, fluent English. It's about as well, they have different meanings, fluent. 2 meanings, 3 meanings. A vessel sink and people sink 8 balls, only a sequence of 0.5. If we add in a pool, then we have 0.8. Evaluating possibilities and their evidence. How we get to this evidence score. For example, in cell divisions, mitosis splits the nucleus, cytokinesis splits the liquid, cushioning the nucleus. Okay, how we can go into it and get a higher score. That cytoplasm is a liquid. Okay, cytoplasm is a fluid surrounding the nucleus. We find maybe somewhere in a text, and then we have. In WordNet, we can look up. WordNet is a big database. Is a fluid is a liquid, and cytoplasm is a fluid, and a fluid is a liquid. And so we have learned: is a fluid liquid? Yes. So we have learned cytoplasm is a liquid, and we can go up with our confidence score in that. Many candidate answers are generated from many different searches. Each possibility is evaluated according to different dimensions of evidence, and just one piece of evidence is the CA. If the CA is of the right answer type, in this case, a liquid. We have a very broad domain of lectural, how it's called? Answer types of LAT answer types. L stands for lexical, exactly. I've said it yet. Okay, and we have they tried to give the different categories and how often the answers came up. In a random sample of 20,000 questions, we found 2,500 distinct types of answers. So it's really, really broad. We have really a lot of different questions. The most frequent occurring less than 3% of the time. The distribution has a very, very long tail. And for each of these types, thousands of different things may be asked. Even when you go to the head, to the top answers, will barely make it end. 30% are non-distinct. They have to they had to look deeper into the contextual meaning to group the 13%. Yes. Okay. Okay. They flew again in. Manually developed rule sets. They had about 30 manually developed rule sets for categories. For example, they had an author, a writer, and writer of author in, actor of actor in, or something like that. For example, Robert Redford and this picket fences star both debuted as soldiers in the 1962 drama War Hunt. He is an... wait a moment. I have written there something I wanted to say. Now... Yes, there. There are three actor in and two actor of relations in this sentence. Robert Redford is actor of War Hunt star, both debuted as soldiers, yeah, actor of War Hunt, and this picket fence star, the picket fence star is actor of War Hunt. They both debuted soldiers in the 1962 drama. The main library of the University of Northern Colorado is named for this alumnus who wrote an Epic of Colorado in 1974. There are name-sharing associations between the focus and another named entity. Yeah, but I'm running almost out of time, so I have to go on a bit further. So the point is, they had about 30 relations they found in the broad LUT, in the lexical answer types. They wanted to go a bit deeper in and manually developed some a bit deeper connections like actor in, actor of. Okay, different types of evidence, keyword evidence. In May 1898, Portugal celebrated the 400th anniversary of this explorer's arrival in India. Okay, when we spread out when we get a bit deeper into the sentence, celebrated in May 1898, 400th anniversary, Portugal arrived in India, explorer. We look for the explorer of this sentence. Now we found in our text search the following sentence. Anyone knows the answer? It wasn't Gary. We're seeing it in the next slide. In May, Gary arrived in India after he celebrated his anniversary in Portugal. Arrived in, celebrated, keyword matching. Yeah, cool. In May, yes, again keyword matching. Anniversary, yes, we are almost right. We had all of the keyword matchings, but it was a different person. So evidence suggests Gary, but the answer Gary is the answer. But the system must learn that keyword matching may be weak relative to other types of evidence. How it's about this sentence. In May 1800, we found another text snippet. On the 27th of May 1498, Vasco da Gama, the right answer, landed in Cabot Beach. Okay, now we have to go deeper in, find the evidence because of the connections. There's some math, a lot of math to do to get sure that landed in and arrival in are connected together. That they meaning the same. That Cabot Beach is a place in India. They have to do some geophysical. They have to know the geophysical that Cabot Beach is in India. And the 27th of May 1498, and 400 years later is 1898. Temporal reasoning. And the presentation won't go on. That's bad. There are a lot of lines more in that, but it won't work. Maybe I can go out and in again. We will go on soon, I hope so. Yes, okay. We can go on. May I have 5 minutes longer, or how we are?
Yeah, sure.
Okay. Not just for fun. Edible rhyme time, the category. Some questions require decomposition and synthesis. Here we have an example for the divide and conquer algorithm for a sort of divide and conquer questions. A long tiresome speech is one part of the question by a throw the pie topping. Someone knows the answer? A long tiresome speech delivered by a throw the pie topping.
Meringue?
Yeah, meringue.
And
Harangue, meringue, harangue. So it has to analyze not the whole sentence, but a part of the sentence and get the answer diatribe and a lot of more, and harangue as well. So, and he find by a throw the pie topping, he find whipped cream, meringue he find as well. So meringue harangue is a possible answer. Meringue harangue. Okay. Evidence profiles. Clue. The clue was Chile shares its longest land border with this country. So we have Argentina on the one hand and Bolivia on the other hand. They are both countries. Classification. The classification, it's a positive evidence that are both countries. That's good. Source location. They are both located close to Argentina, so they found it right as well. They have a common border, both of them. Passage support and popularity. Popularity is important. Why Bolivia here wins? Bolivia is more popular due to a commonly discussed border dispute. But Watson learns that Argentina has better evidence because they had a lot of sources from Argentina and only a few sources where Bolivia was mentioned. Yes, and so they came up with the right answer, Argentina. In category learning, I think I go to this really fast. When at first we have the category celebration of the month, and at first he came up with a wrong answer. The correct answer would be June, and he gave the answer Runnymede, the day anniversary Magna and Carta Day. And so he, after step by step, learns that he has to answer with months. And at the fourth question, he in one category he learned, okay, in this category it's only possible to answer with months, and he gives a month as an answer. And the last two questions he had right.
Cities leading newspapers.
And here it's another example for that.
Houston, also San Francisco. Cora.
What's the Chronicle?
Good.
If you look here down, his confidence.
Here we go. Cleveland, Ohio. Cora.
What's the Plain Dealer?
Nicely done.
1200.
1200 it is. Charlotte, North Carolina. Cora.
What's the Observer?
Nicely done. The Charlotte Observer.
16.
16 it is. Indianapolis. Cora.
What is Stock?
So he got more and more confidence to answer with a possible with a newspaper from that city. And the last two answers he had right, even if he wasn't fast enough to buzz in. Okay, next page. Yeah, you make it. The progress, the baseline we saw 2007. They had this confidence, and step by step they got up into the winner's cloud and finally played against Ken Jennings and Brad. We will see it later, the next slide. But again, they tried to perform analysis, Jeopardy and track. On track questions, the Deep QA, the Watson, performed in 2008 this accuracy, and with Jeopardy questions an accuracy of 52%. And you can see in 2005 in the 2007 system of track winners only performed really bad in it. Yeah, Ken Jennings and Brad Rutter, finally they compete against them.
First choice.
Let's take alternate meanings for 200, Alex.
Four-letter word for a vantage point.
For that they
or a
worked
belief.
all the time, and
Brad,
then
first
finally...
you. Yes.
Alternate meanings 400.
Four-letter word for the iron fitting on the hoof of a horse or a card dealing box in a casino. Watson,
What is chip?
you are right. You get to pick.
Literary character ATV for 800.
So that was the game they worked for, and they had around 55 sparring games before that final game. And did they have? Yeah, and Watson won at the game with a huge amount of money, 72,000, and the others had around about 21,000. That was the final score after a 3-day tournament against Watson. But the question is, would Watson had won if he only would have played against one good player and one bad player? Now they are both very, very good players. Brad, I don't know. One had the biggest amount of money ever won in Jeopardy, and Ken Jennings, the guy on the left, he won 74 games in a row. So they both parted all the questions half and half, which Watson didn't strike to get in. In fact, 2 questions before the end, Ken Jennings had still the chance to win the whole game. There was a daily double, so he could have doubled all his amount of money, and then the final game question, he would have doubled it as well again. So it wasn't that easy to win it, or yes. Okay, I wanted to tell you still some facts about the machine Watson, but I think that's not that important. Then we go on. Yeah, that's the hardware of Watson. And yeah, Watson, 10 computer racks, 80 kilowatts of power, 20 tons of cooling. A human, only one brain, fits in a shoebox, can run on a good sandwich, can be cooled with a handheld paper fan. So it's we have a lot of advantages still to the computer system. Yes, and this I'm going to go over as well. But the future of Watson in healthcare and life science, when doctors treat a patient, they can still diagnostic assistance to get the right diagnostic about the history of the patient, or all the data they have, they can analyze better. Technical support in help desk, contact centers, enterprise knowledge management and business intelligence, government, improved information sharing and security. And now in the news is that Watson Group has launched in the 9th of January 2014. So it's very actual. They have now IBM announces that he wants to invest $1 billion. One of the top innovations in IBM history, they claim. Yet 2,000 employees. They started this 4 years with 20 employees, and after that 4 years, the first time they wrote about it again. That 4 years they don't publicated any papers, so it was a great risk behind it as well. Hopes in 2015 20 billion revenue, and Watson operates now 24 times faster while taking up 90% less space. So thank you for your attention, and if you have any questions, please feel free to ask me.
Okay, thank you.
Okay, I can make it. Yes, are there any questions? Yeah, please.
So I had a question about the interpretation of confidence scores. And this might sound silly if I try to say it. It's hard to express. You can be confident about something being partially true, or you can be not confident that something is entirely true. And I guess when I think about this being the case, when we're talking about, let's say, partial class membership, you know, when we study polymorphism, you can say that this is a member of both this parent class and this parent class.
Yes.
And thus, if I say, is it a X, maybe the correct answer might be half of it or something like that. So I
Yes.
guess what I wanted to know is, are we to interpret the confidence score strictly as Watson's confidence in itself or a belief in the ground truth? And I don't, does that make sense even?
He has to believe in itself, in the data he has. It's the ground truth. The ground truth is what we know, what it's reality. But Watson knows it because of his data. Or I don't know exactly how to answer this question. It's about yeah. There are many betting strategies as well. When when it's a later game and he have a lot of money, he buzzes fast. He buzzes not so fast in, but he have not so much money and the opponents are very good. He buzzes in faster. Yeah, who cares? Now I have to win. Now I have to go on. And this confidence bar he has, it's only his confidence he built up about the data he had. I don't know.
I don't know how to explain it any better, but I'll think about it if I'm trying to reword it maybe.
Yeah, I don't know actually how to go deeper.
So in Jeopardy, you have the answer and you have to give the question to the answer.
Exactly.
And in the track competition, you it's the other way around.
Yes.
So what's the problem for Watson? These two.
It's not so difficult, or it's not so big difference to change the answer you have given in Jeopardy to a question. It's almost the same structure. You have only to put in front what is or who is, and then you have a question. But yes, it was a big, a big thing to change the system that it can work on Jeopardy questions, because the Jeopardy questions are not small questions of 10 words or 5 words. There are sometimes big questions with hidden meanings, sub-clues and all that kind of things. Was yeah? Okay.
Any more questions?
I have another question.
Okay, try.
There's a thing on source reliability I noticed.
Mm-hmm.
I was in the Argentina, Chile.
Yes.
Is that something that is computed, or is that determined by the researchers ahead of time? In other words, is reliability somehow a consensus measure, or do they say, well, Wikipedia is an okay source, but IMDb is better?
No. It was the confidence score he built up by itself. It's an artificial intelligence. He built it up when he got 20 times correct answers from Wikipedia, so the confidence score is going up every time he gets another right answer of Wikipedia. So as well, when the data from the New York Times is 50 times correct and 20 times wrong, okay, that would be very bad, but it gets up every time he gets a right answer, and the confidence score gets down from a source every time the source gives a wrong answer.
That's strange. I mean, the source could be completely factual, just the wrong answer is produced.
Yes, maybe, but the source is Wikipedia. The text where the answer came from was Wikipedia. But yes. They go to make the score higher for one source if they get a correct answer, like this. I got it. Yes, they build up confidence in something or not. Okay, if there aren't any more questions, thank you for your attention.
Thank you again.